For over a decade, Alias has had a refined set of tools that efficiently bring scanned data into high-quality surfaces. These tools lies in the Mesh Toolkit in the palette. With the 2016 launch, I will show you a new approach working with scanned data. There are 3 tools that will be covered in this scanned data section. But before working on these tools, I want to set up my scanned data. By using Curvature Analysis and reducing down the visibility of the scans, I get a better understanding of the shape. I'm using Principal Max Curvature Analysis. This provides a great way to see sharp edges in the scan. It is easy to adjust the scale of the analysis. This allows me to accentuate areas that I want to concentrate on. I will start with the Mesh Subset tool. This is a tool that has been in Alias for some time and relied on the lasso feature for selecting meshes. As you can see with this release, there are 2 new selection methods, normal angle and brush. As you hold down the mouse, Alias responds finding mesh patches that fit within the max angle tolerance. Look how well the normal angle is stopping at the edge as I select near the wheel well. I use the normal angle in conjunction with the brush tool. In these tools, I use the left mouse button to select meshes. I can use the right mouse button to deselect meshes. As such, I can use the brush like an eraser. Because I have the Make Subsets Invisible turned on, when I hit spacebar to subset the mesh, the selected mesh becomes invisible. This makes it much easier for me to see what I want to work on. As I'm selecting the data, if I accidentally go over the edge, I can easily use the right mouse button at any time to deselect. Now that I'm done with subsetting the meshes, let me make all the meshes visible and switch to a random color mode. FitScan has been revised for 2016. The new behavior bypasses the need to create a reference surface before starting the FitScan operation. Instead, all of the work is done directly on the scan. Just lay out the 4 corners of the patch and build. The surface is created and then fit to the scan. When creating surfaces from scan, use random colors and look for a marbling effect showing the surface and the scan are very tight to each other. This surface now has history and can be modified within the session or later by using the Query Edit tool. At the start of the creation mode, I turn Deviation Check on. This feature allows me to see the deviation between the surface and the mesh. Surface from Mesh is a new tool for 2016. Looking at the interface, the selection mode looks common to the Mesh Subset tool, with the addition of curvature. Therefore, I'll use curvature since it's new. There are 3 creation modes for the Surface from Mesh tool. I will look at each one separately and start with the simple surface. As I select the scan and then click to start capturing the meshes, in this case, Alias automatically grabs all of the selected mesh. This is because the curvature of the mesh layout falls within the min radius limit. If I hadn't subsetted this area, a much larger area would have been selected. When I tell Alias to build, a 4-sided surface is created, resting nicely on the scan. The simple surface keeps the entire surface within the selected scan, and tends to be the tightest tolerance surface. I can use the green triad on the corner of the surface to adjust the location of the corner. This is a good practice to minimize the deviation. When I turn Deviation Check on, I can see that the maximum deviation is at about 1.14. By adjusting the surface degree, I can create a tighter surface on the mesh. The Mesh Boundary Creation mode will attempt to create a natural surface as close to the boundaries of the selected mesh as possible. This is an untrimmed surface, and this works well with tools such as align. The final creation mode is the theoretical surface. In this mode, Alias will build a surface whose boundaries extend beyond the edges of the selected mesh.